Hey everyone, it's Mikki here. You're listening to Mini Mikkipedia on a Monday, and today I want to chat about a new review article that has been published in the last, I think it's been about a month now, on creatine, and a highlight on where the research stands with some of the common questions. Now, of course, you will know that I have chatted to Darren Kando a couple of times on the podcast about creatine, but I have to say, despite the proliferation of information out there about it, it is still one of the main things that I get questions on. And the first couple of episodes that Darren and I spoke on, we spoke about the review that was released in 2021 that was common questions and misconceptions about creatine supplementation. And this, which was released this month from the Journal of International Society of Sports Nutrition, is part 2. And so again, it's addressing some of the common questions and misconceptions that arise up on social media. So I thought that this would be a great opportunity to go through this sort of second set of questions and misconceptions, if you like, and then just highlight what the research shows. There are a number of topics covered in this area, and I will just go over them broadly. And of course, I will link to the review article in the show notes. So you can also, if you're interested, go and do a deeper dive into this. But there were some great topics covered. And for those of you who are unfamiliar with creatine, it is one of the most studied supplements available. And to date, there are over 1,000 peer-reviewed papers involving creatine monohydrate. And collectively, it appears safe, and is one of the most effective dietary interventions for improving aspects of sport, exercise performance, and health across the lifespan. And this review paper brought together a number of creatine research experts to perform this narrative review. So one of the first questions they address is whether creatine monohydrate provides muscle benefits without exercise. And creatine is primarily stored within skeletal muscle and does help facilitate the production of adenosine triphosphate within the cell. So it does serve an important role in energy production. So as a result of this, there is some evidence that creatine monohydrate without an exercise intervention can significantly increase total creatine stores and may improve exercise performance. And just to remind you, dietary creatine, we get around about 3 grams from our diet if you're someone who consumes animal protein. And if you don't, then you do not get any creatine because it is only sort of available there. What the research shows is that protocols of around either by creatine loading, having 20 grams a day for around 4 to 10 days, or ingesting 3 grams a day, which is more sort of typical of what you would do for about a month or 28 days, does increase intramuscular creatine levels. And this may actually help explain some of those improvements that we do see in studies that look at things like upper and lower body strength, anaerobic and physical working capacity, and sprint performance in healthy individuals despite no exercise intervention. So really and the paper itself goes through a number of the different trials that they reviewed and concluded that creatine can provide some muscle performance benefits even without exercise. And of course, populations with lower baseline creatine levels, such as vegans and vegetarians, may experience a greater response to creatine monohydrate. And I would say that it's also true of just females probably, because we carry less muscle, so we have less muscle creatine stores. And of course, we eat less animal protein. So the second question they addressed was whether the timing of creatine monohydrate ingestion matters. And you probably won't remember this, but I do. When I spoke to Darren Kando, he said, well, it doesn't really matter, but I mix it in with my protein after my training. And that was just him, not necessarily based on research, but just his personal protocol. So the notion that the timing of creatine sort of might influence these physiological adaptations has historically relied on speculative mechanisms influenced by exercise duration and intensity, and this could theoretically affect the delivery and uptake of creatine by skeletal muscle tissue. And the reality is, though, that a number of studies are a little bit too small and don't really have the appropriate rigor when they were set up in their design to actually assess if timing matters. The review goes on to address a number of different studies that were set up to assess the timing of creatine monohydrate. And it's fair to say that the research is mixed. And again, it has notable limitations, such as the lack of an actual creatine retention measurement. So seeing how much creatine people were able to hold on to. And there's been this inability to determine a time course of creatine uptake during a resistance training program as a function of that supplement strategy. So really what the research tells us right now is that we don't really know, and it doesn't really validate that the timing of creatine is critically important in relation to long-term resistance training, because both pre and post-exercise creatine monohydrate seems equally effective in promoting resistance training-mediated gains in lean tissue accretion, so gaining muscle, and also performance. And so at the moment, what we appear to have is that it's consistent ingestion of creatine during a resistance training program is most likely to be the most important variable to consider, albeit, as I mentioned earlier, Darren takes his post-exercise. And leading on from that is, does the addition of other compounds to creatine monohydrate enhance its effectiveness? So whether or not we should be taking it with some protein or with some glucose, which is what we used to do back in maybe 30 years ago in the 90s, does this actually enhance the work of creatine? There is evidence that creatine uptake into skeletal muscle can be enhanced by glucose ingestion and or insulin. And this is based on a number of different trials looking at either dextrose or glucose with 5 grams of creatine, and found that it did promote greater creatine retention over time. And other studies have shown that creatine monohydrate had favorable effects on glycogen resynthesis, so the ability to restock our muscle glycogen or carbohydrate stores. However, despite this sort of an increase in the creatine uptake and retention, studies have been quite limited to show that this combination of creatine and carbohydrates or other insulin sensitizing nutrients actually leads to greater changes in body composition or performance. So actually meaningful outcomes, or that it affects the maximal levels attained after a period of supplementation. So really it's, you might get a greater increase in creatine by having it with glucose, but that doesn't necessarily have a meaningful outcome to performance or body composition. There's also been interest as to whether protein or beta hydroxy beta methylbutyrate or HMB can enhance the effectiveness of creatine monohydrate. And there is some evidence to suggest that the addition of protein does result in greater creatine uptake and retention. And there are some studies showing that there is an increase in absolute power when you take creatine along with HMB as well in a rowing exercise test in endurance-trained young male athletes. However, other studies find there is no greater benefit with the combination of the two with regards to changes in body composition or muscle performance compared to just creatine monohydrate alone. So again, the research is mixed there. Something else that has been studied is to whether taking creatine with glycerol in water can promote greater fluid retention, better than glycerol with water, which used to be used as a technique to help sort of increase water loading. And these studies generally indicate that co-ingesting creatine with glycerol for 7 days does increase total body water without altering plasma volume. So therefore, this does improve thermoregulation during exercise in hot and humid environments. And there are a few studies actually showing that, which is interesting. Ultimately, though, you can read more in depth in the review article, but there is some evidence that the combination of creatine monohydrate with other ergogenic compounds such as carbohydrate and protein can accelerate that creatine accumulation and retention. And in some instances, such as that increase in absolute power, it does increase some exercise-related training adaptations. But there were a number of studies in that section that I just chatted about where there was no real difference either. So probably, it's a little bit mixed with that regard. So the next question, does creatine monohydrate and caffeine oppose each other? I get this a lot because you'll see many pre-workout supplements have both creatine and caffeine, but people do wonder whether putting creatine in their coffee is going to dissolve, I suppose, the creatine sort of effects. Now, they both actually have independent ergogenic mechanisms. So they both work in different ways to help improve performance. And in fact, caffeine might actually help the action of creatine in the muscle cell. There is also, though, evidence that caffeine might work against some of those ergogenic effects on creatine because of the opposing effects on some of the physiology that occurs within that muscle cell. For example, it might delay relaxation times and might reduce exercise performance. And it's also been theorized that taking creatine along with caffeine could increase symptoms of gastrointestinal distress, which both of these things do independent of each other. But in summary, short-term creatine monohydrate and caffeine ingestion, so less than 5 milligrams per kg per day, which is sort of within that zone of 3 to 6 milligrams, which you would use caffeine for sports performance, likely doesn't really cause opposing muscle effects. So there's no problem taking them both together. The long-term possible interference effects of creatine and caffeine, we don't know about, actually. There haven't been any studies looking at that. In summary, short-term creatine monohydrate and caffeine ingestion at levels of less than 5 milligrams per kg per day doesn't cause opposing muscle effects. So there's no problem taking your 3 grams of creatine, 3 to 5 grams of creatine, along with having a cup of coffee, essentially. And chronic caffeine use combined with creatine loading, so having that 20 grams a day, doesn't really result in greater exercise effects. And in fact, that combined strategy might increase gastrointestinal distress and might indirectly interfere with performance through that avenue. So there's no problem taking caffeine and creatine together as far as the literature goes. You just have to figure out what's going to work best for you. Like, are you someone that gets an upset stomach by loading with creatine or having caffeine or taking them both together? Because if you are, you just might want to rethink that. Now, this is an interesting question, actually, this next one. If creatine monohydrate influences the rate of muscle protein synthesis, or does it change the rate of breakdown? And so there have been a number of studies examining whether or not creatine helps build muscle, or does it just stop it breaking down? And these studies have only been examined in men. And in summary, what it shows is that creatine doesn't increase the rate of muscle protein synthesis. However, it does support the anti-catabolic effects. So it does reduce the amount of muscle protein breakdown. So this is the action with which it helps with our overall skeletal muscle. The next area that they look at is whether creatine is an anti-inflammatory intervention. And there is preliminary evidence that it can reduce markers of oxidative stress and the inflammatory process in humans. So it does suggest a possible anti-inflammatory role in a variety of cell and tissue types. But we don't know how it really works. It has been studied in the context of a 3-kilometer race and how you have less of an increase in these inflammatory cytokines like plasma, TNF alpha, and PGE2 compared to placebo. It's also looked at 5 days at a dose of 20 grams a day, so a loading protocol before a half Ironman competition reduced the increase in plasma levels of TNF alpha and other inflammatory cytokines at 24 and 48 hours following competition compared to placebo. And then in an aerobic exercise scenario, creatine monohydrate for 7 days at a daily dose of 0.3 grams per kg prior to repeated sprint exercises resulted again in a reduction in TNF alpha and something called C-reactive protein, another marker of inflammation, at 1 hour post-exercise, but had no other impact on other oxidative stress markers such as superoxide dismutase, which is our endogenous antioxidant, and catalase. And other studies found no real difference on C-reactive protein concentrations following acute resistance exercise. So 5 sets of 15 to 20 reps at 50% of your 1 repetition maximum for a back squat exercise. So collectively, it suggests that creatine monohydrate might be anti-inflammatory following aerobic exercise, but there aren't that many studies really in that sort of resistance training space, and it might actually be related to exercise volume and not exercise modality. So we just need further studies to look at that. They asked the question whether creatine might increase recovery following injury, surgery, and or immobilization, so just bed rest, essentially. Ultimately, while mechanistic and preclinical data suggests that it might have the potential to enhance recovery following surgery or injury, actual human clinical data does remain scarce and is conflicting. So there are just confounding variables with the studies that have been conducted, including the protocol for creatine, whether it's short or long term, whether it's in combination with other therapies such as exercise rehab, and what type of condition is being studied, whether it's this permanent injury, whether it's just a transient injury, whether it is a neuromuscular or it's an orthopedic injury. And basically, there just needs to be more well-powered randomized controlled trials to address those gaps. I would say, though, you've probably got nothing to lose from taking creatine regardless, and it could be it might help you in that instance of if you do become injured, to potentially load at 20 grams a day for about 5 days or 7 days, which is what some of these studies have done, and then continue on with a smaller dose of about 5 grams of creatine. This is a question I get a lot about creatine. It's whether or not creatine influences blood pressure. And there's been some speculation that it could, due to a number of factors such as fluid retention within cells and increased stress on kidney function. In addition, creatine kinase, the enzyme involved in the process by which phosphate creatine phosphorylates ADP to ATP, is actually high in resistant arteries, and it might be involved with vasoconstriction to increase blood pressure. There have been a number of studies looking at this in clinical populations and in healthy individuals. And in summary, there is no evidence that short-term or chronic creatine monohydrate adversely affects blood pressure. So, and I do get asked that a lot, so there's nothing to suggest that it would make a difference to your blood pressure if you're worried about that at all. When we're considering pregnant women, there is no reason to suggest that creatine is not safe, but there hasn't been a lot of research in it, so it's just good to sort of have that caveat. And when we're thinking about adolescents, there is research to show that creatine may improve measures of sport-specific activities and indices of physical performance for male adolescents, but there is no research in female adolescents, and we do need more long-term randomized controlled trials to examine changes in training adaptations in adolescent populations to fully assess that question. But currently we know that in male population for adolescents, it might be helpful, and it's certainly not unsafe. Now, there have also is a suggestion that the brain requires a higher dose of creatine monohydrate than skeletal muscle to get some noticeable effects. And it could well be different for these different areas. And the reality is that while we're quite set on that sort of 3 grams a day as a minimum, across a longer period of time, you can really see the muscular benefits of creatine. There's not a lot of evidence or understanding regarding the optimal dose to increase brain creatine levels. There have been a few studies showing that a high dose at 0.35 grams per kilogram, more than 20 grams a day for 7 days, or 4 to 5 grams a day for several months can increase total brain creatine levels in both young and older adults. But also, there have been studies that have found no effect after 7 days with around 20 grams. And importantly, creatine monohydrate increases brain creatine levels by around 5 or 10% compared to a 20 to 40% increase in skeletal muscle. So the divergent responses may be associated with the endogenous synthesis of creatine in the brain, the inability for creatine to get over the blood-brain barrier, but also the dose and duration of creatine monohydrate sort of supplementation. So it's unclear whether the brain requires higher doses of creatine compared to skeletal muscle. Currently, we don't really know what dose and what the time-response relationship is for the brain creatine compared to what we know about muscle. The second to last thing I want to address, there are more actually in the paper, but I'm not going through all of them, but the second to last one is whether or not creatine can help with sleep deprivation. And I talk about this a lot from some of these earlier studies. And what the research tells us actually is that creatine might have a positive effect on cognitive processing under conditions of sleep deprivation. The research has only been done in young adults, but I do always suggest to people to try taking creatine if they've had a night of sleep deprivation, because it might help brain function in that instance, but it's not going to help cognition if you've had adequate sleep. And some of the trials that have looked at this have looked at higher doses of creatine at about 0.35 grams per kilogram body weight. So it is a little bit more than what you would use if you were just loading creatine for muscle. There have been trials looking at creatine as an acute dose at about that 3 to 5 grams a day, and they haven't really been found to have any real effect on cognitive function at that level under conditions, even with conditions of sleep deprivation. And finally, when we're looking at creatine for traumatic brain injury, there's a small body of research involving animal and patient populations suggesting that it might reduce severity and or improve recovery from TBI. And it makes sense that creatine for individuals at high risk of TBI, such as athletes and military personnel, is a sensible option for them. There has been a study looking at post-brain injury in children, and 6 months of creatine at 0.4 grams per kg per day in children and adolescents from the ages of 1 to 18 revealed many benefits, including decreased duration of post-traumatic amnesia, intubation time and intensive care unit stay, improved disability, recovery, self-care, communication, locomotion, sociability, and cognitive and neurophysical function. It also helped improve post-traumatic headaches, dizziness, and fatigue, which are commonly reported as lingering problems of TBI. So there are many potential benefits from taking creatine for children and adolescents under the condition of traumatic brain injury. And it's worth noting that there is data from another trial that showed persistent longer-term changes to cognitive, behavioural and mood symptoms are related to reduced brain creatine in retired players from the NFL, age 40 to 69, suggesting that if you lift those creatine levels of the brain, they may not have some of these side effects of the concussion that they may have experienced during their careers. So, there is definitely potential benefit from having creatine under those conditions. Anyway, as I said, I will link to this review article in the show notes so you can have a deep dive yourself, because there's a lot of physiological and mechanistic data and elements that I did not go into because it doesn't make for an interesting read. I did really just want to pull some highlights out from it. And it's a really comprehensive paper. And I will also link to the part 1 paper. So this was part 2. I would also like to remind you guys before I end the call today that I have my webinar, Unlocking Metabolic Mastery, that is taking place on Wednesday, the 29th of January at 1 p.m. and 7 p.m. New Zealand time. So if you're listening to this when it is released next week, that is the week following. So I would love to see you there. We'll put a link to that in the show notes as well. Until then, though, you can catch me over on Instagram, Threads, and Twitter at Mikki Williden, Facebook at Mikki Williden Nutrition, or head to my website, mikkiwilliden.com, and sign up to that webinar. All right, team, have the best week. See you later.